Alright, in this video I'll pick up with problem 9 on our laws of exponents. So to simplify these problems, we have an expression raised to the second power and an expression raised to the negative third power. Just like we explained in class, the first thing we want you to do is put understood exponents of 1 where you do not see them. Then apply your power property, which says we should multiply exponents. So this will give us 3 squared, a to the 8th, b to the 10th, 2 to the negative 3rd, a to the negative 12th, and b to the negative 9th. Your next step is to add a fraction bar, a vinculum, and then move any components that have negative exponents to the opposite side of the vinculum. So we will cross out 2 to the negative 3rd and write that as 2 cubed, a to the 12th, b to the 9th. And then we will simplify. 3 squared means 3 times 3, which is 9. And we have a to the 8th, b to the 10th. And in our denominator, 2 cubed is 2 times 2 times 2, which is 8. You can put that in your calculator if you'd like. A to the 12th, b to the 9th. We are not through because our 3 rules for knowing we are finished is that our fraction is simplified and we only have one of each variable and we have all positive exponents. And at this point they're all positive, but we have an a here and an a here, and we only want one a. So 9 over 8, if we put that in our calculator and try to reduce it, it will not reduce, so 9 over 8 remains. Our exponent is larger on the bottom for a, and then we subtract. 12 minus 8 is 4. And on top, our b is larger. We have more b's on top. 10 minus 9 is 1. So we do not need to put the understood 1. But we know we're done because 9 over 8 cannot be reduced. I have one of each variable, and all of my exponents are positive. For number 10, I have a quotient here. Recognize that we have one component here with a negative exponent. I'm going to cross that out and move that to the bottom. And then simplify. So my b's, I have b's on both the top and the bottom. I have 5 b's up top and 2 of them on the bottom. So it's larger on the top. My exponent is larger on the top, so b remains on top, and subtract these 2 from this 5. So 5 minus 2 is 3. And then on the bottom, I have a squared and a squared. Remember that when you are multiplying exponent, or like bases, you add exponents. So this will give us a to the 4th. If you would prefer, you can expand it all out. 1, 2, 3, 4, 5 b's. I have 2 a's, 2 b's, and 2 more a's. 2 of the b's cancel, and there are your 3 b's. So b cubed, and here's your 4 a's, so a to the 4th. So if you like expanding it out, you're welcome to do that. Next, for 11, we have a quotient raised to a negative power. Similar to number 9, we are going to put understood exponents of 1 on the negative 2 and on the 3, and also on the z because we don't see it. It's understood to be 1. Power to a power, we're going to multiply exponents. So this gives us negative 2 to the negative 3rd power, x to the positive 6, y to the negative 15th. In our denominator, 3 to the negative 3rd, x to the negative 12th, y to the positive 6, and z to the negative 3. We have to be exact with that, so if you need to put the products in your calculator to multiply and get them right, do that. At this point, similar to number 9, we are going to move anything with a negative power. I'm going to put parentheses around this negative 2, and all of that will get moved to the bottom. But remember that even if you have a negative number raised to a negative power, only the sign of the power will change. So my negative 2 will be now to the positive 3rd power. My x to the 6th stays on top. My y to the 15th will get moved to the bottom. Now when I look on the bottom, I have 3 to the negative 3rd. That will get moved to the top. X to the negative 12th will get moved to the top. Y to the 6th is positive exponent, so we leave it. And then z to the negative 3rd will get moved to the top. When I simplify, I want to make sure that my coefficients go first. So I have 3 to the third power. Please put that in your calculator if you like, or remember that this is 3 times 3 times 3, which is 9 times 3, or 27. Up top, I also have x to the 6th and x to the 12th. I am multiplying like basis, so I will add those exponents. And then I have z to the third. In my denominator, negative 2 to the third power, put that in your calculator if you like, but it means negative 2 times negative 2 times negative 2, and that will give you negative 8. I have y to the 15th and y to the 6th being multiplied, so I need to add their exponents. 15 plus 6 is 21. Now we'll check to see if I'm through by putting 27 over negative 8 in my calculator. Hit math, enter, enter, and see if it changes. If it does not, we can leave it. I have one of each variable, and all of my exponents are positive. So I am through. Hopefully you understand that. We've done tons and tons of warm-ups on that. All right, flip over to the back, and now we're going to be simplifying radical expressions. So we have the square root of 40, which is not a perfect square. So if we do our factor ladder with a 40 inside, we recognize that 40 is an even number, so I can use 2. 2 goes into 40 20 times. Also even, so I'm going to divide by 2. 2 goes into 20 10 times. 10 is also even. It divides by 2, and we get 5. So 2 times 2 times 2 times 5 should give us 40. So what this now means is I have the square root of 3 2's, a 5, 3 x's, 4 y's, and a z. You do not have to do it this long way, but I'm doing it for anybody who needs help. So if my index is 2, I'm looking for pairs of factors. So if I can pair something up, it comes out. So a 2 is going to come out. 1x will come out. And 2 y's will come out. So I'll write that as y squared. Anything left remains under the radical. So I have 2 times 5, which is 10, an x, and a z. Now, some of you may have done or recognized perfect square factors, as in the square root of 4 times the square root of 10, where the square root of 4 is 2, and the square root of 10 cannot be simplified. So however you do it, one of these ways should make sense. For 13, we have the opposite of the square root of 25a to the 10th. The opposite means our negative, unless we have some kind of negative come out, which we will not for a square root, we keep our answer as negative. And this happens to be a perfect square because we can take the square root of 25 and we have an even exponent. So our answer will be negative 5a to the 5th. For 14, we are dividing radicals, and when we do so, we need to rationalize the denominator. So remember to create a fraction whose value is 1, where we repeat the radical in the denominator for our numerator and denominator over here, because this really just equals 1. So we're not changing its value. To simplify this, we remember that we just multiply numerators and denominators, so this will give us the square root of 10 over the square root of 4, or the square root of 10 over 2. Do not reduce this. If this is square root of 10, we cannot reduce it with a 2. This is an irrational number. This is rational. We can only reduce rational numbers together or irrational numbers together. For number 15, we have the square root of 8 over 2 square roots of 3. To rationalize this, we only need to multiply by the irrational part. So this will give us the square root of 24 on the top, because these are both in our radical. We're allowed to multiply them. And on the bottom, 2 square roots of 9, which is just 2 times 3, or 6. So at this point, I have the square root of 24 over 6. However, we are not through if we can reduce the square root of 24. The square root of 24 is the square root of 4 times the square root of 6. Because we want to use 4 and 6 because 4 is a perfect square. So that gives us 2 square roots of 6 over 6. If you prefer to come up here, by the way, and break down 24, you can do that. That also gives you your 2 square root of 6. Then you're welcome to do that. These rational parts can be reduced. 2 goes into 6 3 times. So we have the square root of 6 over 3. So come over here and just write square root of 6 over 3 and make sure you put a box or a circle around it.